Okay. Good morning, students. So let us continue with exercise 6.2. So we are starting with question number 7, part 1. Okay. Limit x tending to 1. The question is 1 by x square minus 1 minus 2 by x to the power 4 minus 1. Limit x tending to 1. So let us check with limit x tending to 1. What are we getting? Okay. So when I put x equals to 1, then I'll be getting 1 square minus 1. That is 1 minus 1, 0. And 1 by 0 is infinity. Similarly, when I put x equals to 1, 1 to the power 4 is also 1, 1 minus 1 is again 0, so 2 by 0 is again infinity. So all in all, I am getting infinity minus infinity form. Now this is the new form that we're learning, okay? 0 by 0 we have done, infinity by infinity we have done, and now we are coming to infinity minus infinity form, okay? So whenever I get infinity minus infinity form, remember that the first thing that we'll do is we'll take the LCM. So let us take the LCM here. Okay, so before I take the LCM, I can simplify this x to the power 4 as x square whole square minus 1 square, which will give me in the form of a square minus b square. So all in all, I'll be getting the factorized form of this expression. Okay, so this remains as same. Using the formula, I'll be getting this factorized form. Now it's easy for me to take the LCM. So this whole thing is going to be the LCM out here in the denominator. So this is the LCM. This and minus gets cancelled out, so x square plus 1 is left out. X square plus 1 into 1 is x square plus 1. This is the whole thing, and this is 1 time, so 1 into 2 is minus 2. Okay, clear till here? Now the next step, minus 2 plus 1 is going to be minus 1. So x square minus 1 is the numerator and divided by this. So these two terms are similar term. It gets cancelled out. Then the 5 will be left with limit x tending to 1, 1 divided by x square plus 1. Now you put x equals to 1, we will not be getting any undefined values. So 1 by 1 plus 1, which is 1 by 2. Okay, so this is how we do. I'll be putting the same, the PDF, the JPG file also in your assignment sections. Okay, so this is explanation of 7 part 1. Now, the next one we move is to question number 9 part 1. 9 part 1. The question is limit x tending to 0. I hope you people are clear in the video. Limit x tending to 0. 1 by x minus 1 by e to the power x minus 1. This is e to the power x minus 1. Okay. Now what we do is we put x equals to 0 again. You put x equals to 0. So therefore I'll be getting 1 by 0. What is 1 by 0? Infinity. Minus e to the power 0. E to the power 0 is 1. And 1 minus 1 is again 0. So what is 1 by 0? 1 by 0 is again infinity. So what is the form? Infinity minus infinity form. So therefore again what we have to do, we have to take the LCM. So let us take the LCM out here. The LCM in this case is going to be x into e to the power x minus 1 within the bracket. Please use the brackets properly. Okay. Here also you can use the bracket. Therefore this will be the box bracket then. Okay. So x gone, e to the power x minus 1 into 1, e to the power x minus 1, e to the power x minus 1, e to the power x minus 1 is gone. Okay, so x, therefore it's clear till here. Next step, what we'll do is we'll simplify this properly. Okay, let us rearrange this properly. E to the power x minus 1. Denominator, what will I do is I will multiply it term by term. X into e to the power x and then x. Okay, as limit x tending to 0, therefore what will I do now is we'll check the limit. We will check the limit. You put x equals to 0. So e to the power 0 is 1. 1 minus 1 gets cancelled out. X is already 0. Numerator is 0. Denominator, with the presence of this x, which is 0. So 0 into any number is 0. And minus x, which is always 0. So the form is 0 by 0 form. So I hope you're clear till here as well. We move to the next step by using LH rule. So by using LH rule, what should I do is differentiate the numerator, differentiate the denominator. Okay, so differentiation of numerator, e to the power x, e to the power x, x, 1, 1, 0. Okay, denominator, the same thing, use u into v rule, keep x constant, differentiate e to the power x, plus e to the power x constant, differentiate x, and then differentiation of x is 1. Okay, again let's rearrange it. Limit x tend to 0, e to the power x minus 1. This is this, this is this, and this is this. Let us check the form once again. Limit x tending to 0. E to the power 0, 1, 1 minus 1, 0. X is 0. Now e to the power x is already 0. So no need to check. 0 into any number is 0. E to the power 0 is 1, 1 minus 1, 0. So hence again the form is 0 by 0 form. So what should we do? Again let us use LH rule. So by LH rule, this will be limit x tending to 0 e to the power x, e to the power x 1, 0, no need to write. Differentiation of the denominator, use u into v rule, keeping x constant, e to the power x plus e to the power x constant, differentiation of x is 1, plus e to the power x differentiation, e to the power x, and differentiation of 1 is 0. So therefore I am not writing it out here. Okay, so now let us check the form. E to the power 0. So e to the power 0 is 1, x is 0, e to the power 0 is 1, e to the power 0 is again 1. So therefore, once I put the limit, then I don't have to write the limit out here. Okay, so therefore I'm not getting any indeterminate forms. Let us simply put the values. E to the power 0 divided by 0 into e to the power 0 plus e to the power 0 plus e to the power 0. We know that e to the power 0 is 1 divided by this is 0 and this is 1, so only 1 plus 1. So hence the final answer would be 1 by 2 as well. Okay, so I hope you people are clear with this. This was your question number 9, part 1. The key point out here to remember is whenever I get infinity minus infinity form, always take the LCM. Once I take the LCM, I'll be getting the numerator and denominator. Then only I'll be able to check, which form it is, either 0 by 0 or infinity by infinity, and then use LH rule, keep on simplifying it, differentiate, okay, and until we get a defined value. So hence in this way we can solve the problems in indeterminate forms. Okay, let's pause the video for a while. Okay, the next question that I'm taking out here is question number 12, part 1. Okay, question number 12, part 1. The question is limit x tending to 0 plus x into log x. Okay, the question is x into log x and limit is x tending to 0. Let us check the form first. So you put x equals to 0, it is 0. You put x equals to 0 and log 0 is infinity. So what is the form? 0 into infinity form. This is again a new form for us. Okay, 0 into infinity form. So therefore 0 into infinity form, which we haven't done before. We have done 0 by 0, we have done infinity by infinity, we have just done infinity minus infinity, and now we are tackling with 0 into infinity form. So what should I do out here? So in this type of cases, 0 into infinity form, let us always, if you are stuck in this type of cases, then what we'll do is we'll convert the form either 0 by 0 or either infinity by infinity. Okay, so therefore what will I do out here is keep this log x as log x. Keep your log x as log x, but this x, keep your log x as log x in the numerator, but your x, I can write this x as 1 by x, because 1 by x after reciprocal it becomes x into log x. Okay, and if I make 1 by x, what happens, and now we check the limit. Log x divided by 1 by x. Now we check the limit. X tending to 0. Log 0. Log 0 is infinity. And 1 by 0, isn't it? 1 divided by 0. 1 divided by 0 is also infinity. So what is the form then? It is infinity by infinity form. I hope you are clear till here. So once it is infinity by infinity form, then again I can use LH rule. So differentiating the numerator, limit x remains as it is. Differentiating the numerator is 1 by x. Differentiating the denominator 1 by x, it is x to the power minus 1. So minus 1, x to the power minus 2. Bring it down, it will be minus 1 by x square. Minus 1 by x square. This minus is a constant which comes outside of the limit. X and square gets cancelled out. Therefore I'll be left with 1 by x. If you take the reciprocal, it will be minus limit x tending to 0 into x. And when you put the value for x equals to 0, it is minus 0. And minus 0, it is always 0. So hence, in this way, we'll tackle this problem of the form 0 into infinity. Okay, so another interesting question, we are moving on to is question number 13, part 1. Okay, the reason why I'm telling interesting is, again, we have to convert the forms out here. Okay, so the question given to us, 13 part 2. Okay, copy the question from the book. 13 part 2, limit x tending to pi by 2. Limit x tending to pi by 2. Bracket 1 minus sin x into tan x. 1 minus sin x into tan x. Let us check the form first. Okay, you put x equals to pi by 2. So sin pi by 2. How much is sin pi by 2? Sin 90. Sin 90 is 1. 1 minus 1 is 0. And tan 90 degree. Tan 0 is 0, but tan 90 is infinity. So what is the form? It is again 0 into infinity form. I hope you're clear with this form. Now, we know that once we got this form 0 into infinity form, we will not be able to differentiate it directly until and unless I don't get 0 by 0 or infinity by infinity form. So what we'll do, we'll try and make in the form of 0 by 0 or infinity by infinity, because only if we do this, then we'll be able to use LH rule further. Okay, so the easiest thing for me out here to do is keeping 1 minus sin x as it is and writing tan x as 1 by tan x, which we can do. Okay, because 1 by tan, we take the reciprocal, it gets multiplied to 1 minus sin x. It goes up in the numerator. Okay, so next step, limit x tending to pi by 2. 1 minus sin x remains as 1 minus sin x, but 1 by tan, what is 1 by tan? We know it is cot. Now let's check the limit. You put x equals to pi by 2, sin pi by 2. 90, 1 minus 1, sin 90 is 1, 1 minus 1, 0, and cot 90 is always 0, because tan 90 is infinity. If tan 90 is infinity, then cot 90 is 0. Simple as that, isn't it? So further, I will do the differentiation and then show the video, okay? Okay, so therefore, it was 0 by 0 form, so we use LH rule quickly. When I use LH rule, 1, 0, ddx of sin x is cos x, so minus cos x. Remember, ddx of 1 is 0, minus, and ddx of sin x is cos x. So minus cos x, differentiation of cot x, very simple, minus cos x square x, minus minus gets cancelled out. Limit x tend to pi by 2, you know, the more you can simplify it, that's better for us, okay? So therefore, what I've done out here is keep cos x as cos x. Now 1 by cos x, my friends, it is sin square x, isn't it? So therefore, we put the limit now. When I put the limit back, cos pi by 2 into now sin pi by 2 whole square. Now sin pi by 2 whole square, sin pi by 2 means sin 90. Sin 90 is 1, cos 90 is 0. So 1 into 0, the answer is 0. Okay, so we'll keep this much from this exercise. I'll be giving the videos as well, so I'll pause this for a while. Okay, last but not the least, your homeworks. So this is your assignment number 2. Yesterday's one was assignment number 1. Do follow the format that I've given in the guidelines. You know, exercise 6.2, question number 8 part 1, number 10 part 1, number 13 part 1. Also do the example number 3, ISA 2010, example number 4, example number 5 part 2, which is ISA 2012. So hence this exercise is also very important for us when it comes for your board exams, okay? So do your exercise 6.1 properly as well as 6.2 properly, and tomorrow we're going to start exercise 6.3, which is the final exercise of this chapter. Okay, I'll see you in the next one.